Welcome to another New Wave Post-Punk Security Hour. This time, imagine a Eurythmics take on software supply chain security with sweet dreams and two lines from the chorus. Some of them want to use you, some of them want to get used by you. That's right, everybody's looking for something. Which means, this week we talk with Manish Gupta from ShiftLeft about spreading AppSec throughout a modern CI pipeline. In the news segment, here comes the rain again for IIS, pre-mortems for when tomorrow comes, the Android security model, avoiding a thorn in your side with Kubernetes, and more. Hold your head up and stay tuned for Application Security Weekly.
This is a Security Weekly production. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. Are you looking for a solution to protect your web apps against the most business-critical security vulnerabilities? Unleash the power of automated ethical hacker knowledge with Detectify for continuous coverage and relevant security vulnerability findings. Upgrade your web app security with speed and scale and start a 2-week free trial at securityweekly.com/Detectify. Go hack yourself. For teams looking to inject some security into the DevOps lifecycle, the Uptick Security Analytics platform offers complete security observability for your cloud workloads, including hosts, VMs, containers, and micro VMs. Uptick analyzes builds in development and at runtime for real-time detection of misconfigurations, vulnerabilities, and malicious behavior. Security Weekly listeners can sign up for a free 2-week trial by visiting securityweekly.com/upticks. When it comes to web app and API security, the choice is simple. You can choose Fastly's security solution that teams will actually use in full blocking mode, just like 90% of their customers. Or you can stick with costly options that you probably just turn on. You can get Fastly's all-in-one platform that protects apps everywhere they live, however they're built. Or departments can agree to disagree. You can go to securityweekly.com/Fastly to learn more. Or you can just wish you had.
This is episode 152, recorded May 24th, 2021. I'm your host, Mike Shima, and I'm here with John Kinsella. Hello, John.
Mr. Shima, happy Monday.
Happy Monday, John. Do you have a specific guest? Not you, John. I know you've got a long list of guests and topics to share. But for listeners, if you have a specific guest or topic that you want us to cover on one of the shows, submit your suggestions for guests by completing the form at securityweekly.com/guests. We check suggestions monthly and will reach out to you once reviewed. Manish has 15 plus years in cybersecurity. He was previously the Chief Product and Strategy Officer at FireEye, helping grow the company from approximately 70 million to more than 700 million in revenue. Prior, he was VP of Product Management for Cisco's $2 billion security portfolio. He also served as VP/GM at McAfee, growing the network security business 5-fold in 5 years. Hello, Manish. Thank you for joining us.
Hi, Mike. How are you?
Doing well, and hopefully just as well as all of these developers that we're shifting left and shifting security responsibility onto. I think that's kind of the theme that we wanted to bring you on and chat about. And to kick things off, let's just kind of talk a little bit about how much of that is a struggle for developers, or what's this problem space or problems that we're creating by saying, hey, developers, you need to be responsible for security. Good luck.
Yeah, it is. So the notion of shifting security left to the developers, look, this is not necessarily a new phenomenon. Historically, even when application security was, I guess, not shifted left, 70% of the work is done by developers. Unlike other security fields, application security has always been onerous to developers because, after all, AppSec might find the vulnerabilities, but they cannot fix them. The fixing of the vulnerabilities has to be done by developers. And so in a waterfall model, in a slow development lifecycle, it was easier for application security to run a scan maybe once a week and throw the results over the wire to the AppSec, to the developers, who would then go fix a few. But in a highly agile, modern CI/CD pipeline, it just makes sense to start to automate some of this and to start moving this to the left so that as developers are developing, application security becomes an integral part of that development lifecycle as opposed to an add-on.
Yeah, and I think there's a couple paths we can go down there. Of course, at least I think I say, of course, the tooling side, just as you mentioned, the automation, just as well as the people side. But since you brought up the automation, maybe let's tackle that first in the sense of, I'm going to say we need tools just to scale, but what does it really mean to be running these tools better or having these tools in a modern CI pipeline? And what I'm kind of teasing apart here is that I think we're talking about, you're at least talking about more than just, rather than the AppSec team running a SaaS tool or an SCA tool and having the developers run the tool, that possibly the tools need to be changing as well. So what does it mean when you see, when you're starting to think about this finding aspect of vulnerabilities? How can that look better within a modern CI pipeline?
Of course. Let's first imagine, a legacy waterfall model, and let's say half a dozen developers are developing a feature, a story, and it takes them, let's say, a month to develop it. Now, they might be doing sort of minor release every week, and at that point, at the end of the day, at the end of the week, AppSec runs that scan on the features or the minor software developments that have taken place in that week. Now, what has just happened? Well, those 6 developers worked iteratively to develop what is now being scanned, let's say, on a Friday. So clearly, perhaps I, as a software developer, made a change, on top of which perhaps, Mike, you made a change, and perhaps on top of that, maybe John made a change. And so by the time Friday arrives and we run that scan, we are analyzing all of these changes put together. So that's the first part to note. Then we give it to the 3 of us, the application scan results to the 3 of us. And now perhaps the scan highlights that, hey, Manish, what you wrote caused a vulnerability, and what you wrote was on Monday. So first of all, between Monday and Friday, what have I been doing as a developer? Clearly not twiddling thumbs. Developers lead a busy life. And so I've probably moved on to my next change that I'm incorporating the code. So now it is contextual shift for me. It's burdensome for me. It's impacting my productivity to go back to something that I wrote on Monday. Software development is a creative exercise. And it is said that it takes a software developer roughly 30 minutes to just get into the context of the code that he or she is working on. So first, as you can notice, we are impacting developer productivity. Second, well, the change was started by me, perhaps, which caused the vulnerability. But on top of my change, you made a change, Mike. And on top of your change, John made a change. And suddenly, I cannot fix this vulnerability all by myself. I have to now work with you and with John. And together, we have to make the required changes in order to fix the vulnerability. That further impacts our productivity. And all of this, notice, is just slowing us down. And so perhaps the feature story that was supposed to be delivered in a month is now not going to be delivered in a month. Maybe it gets pushed out by a week or 2 weeks. Now, this is where the third part comes in, which is us software developers don't get compensated based on writing secure code. We get compensated to deliver features on time. And so what do you think we will all do? Well, of course, we will just ignore the vulnerability because it's impacting our release time by 2 weeks and just continue to publish the code with that vulnerability, which is precisely why, majority of the vulnerabilities found are not fixed before they show up in production.
So I think a quick note, Manish, you sound great, but maybe we've lost your video on Zoom. Maybe just a quick turn it on and off again might help us. But your message is coming through pretty clear, just in that sense of that burden on developers and having to do that context switch. And to me, it sounds like too you're starting to have that description of security as a quality aspect of software, which I think I would agree with. One of the things too is that there's an angle here about, are these vulnerabilities, do we have to fix every single vulnerability that comes through, or does every single vulnerability have the same priority? And here again, talk about that idea of just what are the dependencies that you're using that maybe are outdated, have a known vulnerability? Is there an exploit path to that vulnerability, to that dependency? In other words, can we put the vulnerabilities into context? And I think that's something too that sounds like it's really helpful for a tool to be able to do, or at least an AppSec team to be able to add that additional business context or even technical context for a vuln. So one of the things, Manish, is kind of coming out of how you're describing this interaction with the developers and specifically the tools, is that there's a software quality aspect, of course, and these tools should better put the vulnerabilities within context. So there's a business context that's being put in place for, is this an important vulnerability or maybe not an important vulnerability? And so I wonder, this has got to be part of this aspect of how to bring the tools better into the CI pipeline. And I'm kind of curious too, as we're talking about these tools, are there aspects of either the qualities of them that you see these are what modern security tools, how they work best within a pipeline, or these are some metrics around the tools that kind of help us measure these are the ones that are useful to developers? So perhaps a two-part or a choose your own adventure question there.
Fair enough, Mike. Now that's a great question. And I think this is, again, another area where the security team, and notice that I'm using the broader term as opposed to just application security, needs to take a fresh look at how to measure application security success. Historically, when application security bought the tool and they were largely responsible for scanning it and giving the results to developers, they were largely just focused on, hey, how many vulnerabilities can this tool find? And so legacy vendors, went from identifying critical vulnerabilities to now identifying a bunch of what they will call informational vulnerabilities. So it's often when we talk to prospects, customers, they'll tell me, oh yeah, I run a scan with tool XYZ and I found 3,000 vulnerabilities. Now, typically what happens when an organization finds 3,000 vulnerabilities, imagine, right? Well, it's just...
Everyone panics.
Exactly.
Yeah.
And let's not do anything because this tool sucks anyways. I mean, who has time to fix 3,000 vulnerabilities? So let's not make any progress at all. Instead, and so this comes to your question, should we be identifying informational vulnerabilities? Yes, perhaps. But no, the real goal of application security program needs to be what percentage or how many vulnerabilities are being fixed, not how many are being found. And number one, how many vulnerabilities are being fixed? And number two, how quickly are they being fixed? Because yes, we are fixing 100 vulnerabilities, but it is taking us like 5 years. Well, that's not really good enough. And so this is where we have focused a lot. This is where the industry needs to focus a lot on. So number one, the tool needs to be super accurate. It needs to have the highest OWASP benchmark, and there needs to be more transparency in the industry around the OWASP benchmark. With antivirus tools or intrusion detection prevention tools, we have third-party testing houses that regularly publish comparative results. There is nothing like that in application security. And there is only one benchmark called the OWASP benchmark, OWASP. Now, there are several vendors who claim, hey, we have a self-serve, come and try our product. You will not be able to find anyone allowing you to run the OWASP benchmark. Well, that tells you something. So this is something that we've become very transparent about. You can come to our tool, just try the OWASP benchmark all by yourself and see how well do we do. So that's one part, which is the accuracy of findings. The other is the contextual part. And you were very right. More recently, in the last 2 or 3 years, we have shifted what is called software composition analysis, SCA, to almost this process of upgrading dependencies automatically. And that's a great innovation. We absolutely needed it because after all, our applications are consisting of more and more dependencies. However, what typically happens is if you're an organization which is more than 2 or 3 years old, well, guess what? You have a bunch of technical debt. And upgrading dependencies is non-trivial. The application will break. Now you need to do unit testing, and then perhaps QA testing, perhaps regression testing, and suddenly upgrading dependencies is non-trivial, is impacting developer productivity. Now, how can we get better at that is precisely what you mentioned. What are we trying to do with upgrading vulnerable dependencies? We are trying to eliminate scenarios where this vulnerable dependency makes my application vulnerable. And so this is where ShiftLeft's innovation about attacker reachability for a vulnerable dependency becomes key. And across our customers, we have found that we reduce the number of dependencies that you have to upgrade to 4%. 4%, meaning we decrease the amount of workload that other SCA vendors are creating by about 96%. That's huge. That is what allows our customers to analyze code very frequently and fix the most number of vulnerabilities in the industry within one sprint. What does one sprint mean? From the time the code was starting to be changed and before it ever shows up in production, it's already been fixed. That, to me, is the measure of application security success.
Yeah, and I think that also gives us a good chance to bring in that aspect of the people and collaboration on top of the tools, because now I think we have a premise that here is a tool that the security team can bring that gives some confidence, that conveys some, I'm losing a good word, but some legitimacy in a choice, just to say, here's something that helps you. It doesn't give you noise. And here I'm using the term noise, not in the sense of accurate or not accurate, but more in the sense of, here's something that gives you the most important things to fix because they have a high priority, they're exploitable, as you said, et cetera. Let's work on those, and then acknowledge from the security side that the developers are working on a lot of other hard problems and other things that SCA or SaaS tools may not find out of the box anyway. So talking about this shift also into this relationship from AppSec and DevOps teams, it sounds like already one, that the DevOps team is more responsible perhaps for running these tools, consuming the results of them. But what else then, how else can the security team, I'm trying to make up a good question here, sorry. What else can a security team do to build a better collaboration with the DevOps side of team or just the developer side of team in a way that brings them security, but doesn't just say, here is the OWASP checklist, speaking of OWASP, and just say, tick off these boxes before you release? Because clearly after 10, 20 years of development, just a checklist-driven security hasn't been working.
Yeah, a great question, Mike. It needs to, I can't tell you how often when we talk to customers, there's almost an animosity between application security and developers. They don't get along very often. Precisely for this very reason is historically application security doing scans and throwing it over the wall to developers makes application security unhappy because they don't see as many vulnerabilities being fixed, and makes developers unhappy because of lack of accuracy of these tools, which only increases their burden. So the first thing that we find, which is very important to do, is think about application security as a collaborative exercise. Application security team has a very important role. They are a mile wide and an inch deep. They don't really understand the details of the code, but they really understand all the code and why it gets deployed and what is customer facing and what is perhaps not, what deals with sensitive data or credit card data and therefore needs to be PCI compliant and things of that nature. Developers, on the other hand, are a mile deep and an inch wide. A single developer will largely know his or her code the best, of course, not necessarily having in-depth knowledge of the rest of the code of an organization. It is this mindset that we got to bring into this collaboration, where application security gets to develop application security policies for the application portfolio. So for example, it could be that I am the AppSec person, and because this particular microservice is customer facing and deals with credit card data, I am wanting to make sure that this microservice does not have any new data leaks, where sensitive data is being written to a sink without appropriate encryption or obfuscation. I might want to make sure that this particular microservice does not have any SQL injection, code injection vulnerabilities. So I can just define that as a rule in ShiftLeft, and that rule gets enforced every time there's a pull request on this microservice. So we just took the application security point of view. Now let's take a look at the developer point of view. I am that developer who's making changes, who's just made a pull request to this microservice. And the rule of thumb, Mike, that we follow at ShiftLeft is from the time a developer makes the change, gets up, goes and grabs a cup of coffee, by the time she is back, she should see the vulnerabilities, if any, caused by her change. So I come back and I notice, I just did this pull request. I get the results from ShiftLeft, and it tells me that, I'm leaking this credit card information to HTTP out without proper encryption. And I know the application security team telling me, hey, this vulnerability is not allowed because of the sensitive nature of this application. So I have not shifted context. This change is very fresh in my mind. After all, I just made it. And so for me to go fix this is far easier than if I were given this vulnerability information hours or days later. That is the collaboration we are talking about. How application security gets to communicate easily the requirements to developers, and developers get to consume this information. That's the second part within their workflow. Modern developers are using some Git-based tool. And so let's just assume GitHub, for example. So I'm in GitHub writing my code. And if an application security program is forcing me to go look at yet another console, that impacts my productivity. That makes me not want to do that anymore. So to the extent that I can consume this information within my workflow, within the GitHub interface, within Jira, because might be my bug tracking system, all of these small elements are hugely important in making sure that we are embracing developers, knowing that they have a lot of other things that they got to do. Application security is just one small part of their responsibility.
Yeah, I think there's a common theme, of course, that we've picked up a lot on this show, just in the sense of bringing the information to where the developers live, as you were saying, within the GitHub repo, within their ticketing system, et cetera. One of the things that I like about just having that repo-oriented or just Git-oriented type of scan and reporting is that you also know more likely who's responsible for the change, not in the sense of blame, but in the sense of being able to say, who should fix it, or who has the context to fix it. And the further you get away from that code commit to running the tool to find a vulnerability, that if you're just doing that on the packaged artifact after it's been deployed, suddenly you have a lot of disconnect between who's responsible for this app or who's responsible for this line of code, in the sense of they need to fix it. So I just wanted to add that part of it too. Why I like that idea of just trying to acknowledge early, acknowledge often about these types of vulns. But I did want to come back to that idea of what vulns perhaps should we be looking at, or the types of vulns we see? Because on the one hand, we have, of course, the OWASP top 10, but I kind of feel that's gotten a little bit dusty over the years and not necessarily keeping up with where the real vulnerabilities happen, or where applications fall down. And of course, as you mentioned, there's SQL injection, there's the ever-present cockroaches of the internet, cross-site scripting. But then we get into the OWASP top 10 with the things like business logic, or as you're kind of saying, just where are data sinks and data flow diagrams. So as we start to try to improve the conversations with developers in the sense of threat modeling or data flows or even just control flows, how have you seen successful approaches from AppSec teams or security teams in general, just bringing this type of security-minded thinking to developers?
Yeah, no, so Mike, we see this most importantly in our data set. The number one category of vulnerabilities that our customers fix the fastest are data exfiltration vulnerabilities. And when we saw this data amongst our customer base, we were thrilled because we clearly saw that what we are trying to drive attention to through identifying vulnerabilities accurately and through data flow, allowing our customers to consume that information, especially developers, in a very digestible manner, is resulting in the output that we would want. As I mentioned earlier, application security success, has to be measured by the percentage of vulnerabilities that are fixed. And I think this is where we asked some of our customers, and more specifically developers, hey, why aren't you fixing some of the vulnerabilities? Like, why aren't you fixing 100%? And of course, one part of the answer is, conflicting priorities. But it was interesting to note for us that The second set of answers we got were, well, I don't know what a SQL injection vulnerability is. I don't know how to fix it. Or I don't know what happens if I don't fix it. And that sort of brings us to another dilemma in application security software development, which is, all companies are hiring software developers a lot, and many of these software developers have recently graduated. And we don't teach cybersecurity very often in schools. And so for the first time, these developers are getting exposed to vulnerabilities in a work environment. So looking at that problem, we came up with what we call ShiftLeft Educate, which is what it is trying to do is if you're a developer, and imagine you're the developer who doesn't know what a SQL injection is, and you find a SQL injection vulnerability, we don't want you to do a Google search because who knows? The way you type the Google search versus I type it, we might get different results and we might land up fixing the vulnerability in slightly different ways and not necessarily always in a correct way. After all, we're talking about just searching the internet. So the idea is to provide what I call just-in-time training. You come to the ShiftLeft dashboard, and right then and there, within a 5 to 10 minute video, we will teach you, if this is, for example, Java code, we will tell you not just JavaScript, not C#, but for Java, because that is what you're writing. So very specific to that language, we will tell you, or teach you rather, what is a SQL injection vulnerability? What happens if you don't fix it? And how should you go fix it? And furthermore, lastly, if the organization so wanted to standardize, like all injection vulnerabilities should be fixed by using one of these 2 or 3 APIs to validate inputs. Perfect. So it almost now becomes, notice application security, has started to become more like a firewall almost, in the sense that we can now enforce that only certain APIs are used so that we start to institute best practices in the software development organization.
Yeah, and that's where I like that idea of much more of that rather than just say stop using string concatenation, more asking that fundamental question, why was string concatenation an option in the first place? Why wasn't there just a simple linting that here are the 2 or 3 APIs for crafting database queries? And it just makes it that much harder by default to misuse them, to abuse them, and introduce injection vulnerabilities. Of course, I think you need a little bit of maturity within a code base to get to that point, but that to me sounds like the smarter, more strategic solution. I did want to go back a little bit what you were saying too on this idea of metrics, and should we fix all of the flaws, all of the vulns, and have our measure of success associated with all of the vulns, or maybe just the measure of the success is you can fix a vuln quickly? Because that was one of the things you mentioned earlier too, and I'm kind of curious, just if you were to bias towards one of the others, what would you fall on? Fix them all or fix quickly the ones that are really impactful?
Fix quickly. Very few organizations in the world have security as their top priority. All right, most commercial organizations will have driving revenue, delivering features, functionality to customers that they want as their number one priority, and as it should be. So yes, we fundamentally believe that the goal of application security is to be how quickly can we fix vulnerabilities, not that we are fixing all of them. It's very much like bugs. When we release software, we would love for it to be bug-free, but that might delay our release cycles by who knows how long. So we do release software with known bugs, and we fix them over time. The same approach needs to be taken with application security. And this is where tools should allow application security to be able to write policies. So as an example, so let's say you are a company which is about 5 years old, or for whatever reason, you've not done application security before. Now, regardless of what tool you run, who knows, maybe you find, let's say, 100 critical vulnerabilities. And now what do? Do you try to fix them all? No. I think many organizations take the approach of, well, let's go fix the super critical ones, let's say data exfiltration vulnerabilities. But then let's put a policy in place that for the foreseeable future, what that needs to be defined by the organization, because we are adopting a new tool, let's make sure we are not introducing new vulnerabilities. And once we start getting better at adopting this application security flow, as we are writing, making new pull requests, as we are finding vulnerabilities, as we are fixing them, there will come a time, let's say 6 months later, where you say, you know what, we've gotten really good at fixing the vulnerabilities we find. Now, let's start taking care of the technical debt.
Yeah, I think the key part for me that what you said there is let's stop introducing new vulnerabilities. And I hear that and just think we're talking about essentially a pretty good just DevOps process. Leave the security side out of it in the sense of here's a bug. We want to fix bugs with confidence. We want to have some good test cases so that we can make sure that we haven't regressed, so that we know that those changes can go out quickly with confidence. And that's that idea, I think, of releasing quickly on a DevOps team just with features. With fixing those bugs that are perhaps known that will be rolled out, that will be addressed in the next sprint. And if we just consider, I say just a little bit of hand waving here, security bugs part of that under that umbrella of quality, if we're able to fix them with confidence quickly, that helps us from a DevOps side. And it just so happens that is better application security that just comes out of that, regardless of whether we have tools finding all these bugs or not. So I just wanted to emphasize that because that speaks to me as just saying good AppSec can come out of good development processes just by not necessarily by chance, but by practice.
You're absolutely right. Modern development practices, first of all, going from monoliths to microservices, smaller attack surface, doing highly agile software development. So instead of making one big change in a week, making incremental changes, all of this assists in getting better at application security. Because if you're making small changes, the likelihood of the application security tool finding a lot of vulnerabilities is minimal. After all, the change was small that was made. So to be able to find just one or two vulnerabilities and be able to give them to developers right after they made the change, as you can see, we're not trying to boil the ocean by saying, oh yeah, I found 100 vulnerabilities. And now you have deer in the headlights look. One or two, easy to go fix. So you're absolutely right. As we become more agile, we are going to get better at application security, provided we use the right technologies, we use the right tools that were built for modern CI/CD. To the extent that we continue to use legacy tools, we are never going to get better. As an example, one of the reports that is published by a legacy vendor says that their customers, and they are large, so they have hundreds and thousands of customers, that their customers, 0.4% of the applications are scanned daily, 0.4%. In our case, 20% of the applications are scanned multiple times daily. So, that is where the world is headed. So it's not like people don't want to scan often. People do want to scan often. After all, they're trying to insert application security into this modern pipeline. But legacy tools just don't allow you to do that.
So I think. Go ahead, John.
You walked into a question on tip my tongue, Manish. And it's interesting because I'll ask it from a different point of view, but we're coming together here. So I'm curious to hear. I'm going to go a little bit Business Security Weekly here for a second, not so much AppSec Weekly. One of the topics we've had on the show, I don't know, over the last few months is, while we are DevSecOps Weekly, and this is what we talk about week in, week out, there's stats out there showing somewhere between 30 to 50% of enterprises are not using automation in their build process. You as a CEO of a company, you've been in the space for ages, we've heard the bio, you know what you're doing, you've been talking really great for the last 20, 25 minutes. But also as an executive of a startup, how do you see, what do you think about, how do you get that group, that percentage of the market, which isn't even thinking about a pull request, to A, do that, and then B, buy your software, right? Because that obviously that allows you guys to increase your own business. But how do we you've mentioned, you've hit it out with the legacy comments, but what's sort of in your mind around that? How do we get those people more on board?
Yeah. So good thing, John, is very rarely do we meet customers, and I'm talking about Fortune 50 customers even, that are not trying to develop faster. Now, this spark might just happen in one small engineering team within one BU. So maybe it represents 5% of the software developers that the company has. But almost everyone, if is trying to move to the cloud. As we've all heard, COVID has only accelerated this. And the movement to the cloud there is this desire to be able to innovate faster. Having said that, that largely speaks to, yes, if you're going to run faster, you need modern AppSec. But I will take the import of your question more to mean, what if you're not doing agile software development? Do you not need modern application security solutions? So I'll focus on that more. So the metric of application security success does not change whether you are running fast or whether you're developing slow. Every company wants to be able to fix vulnerabilities faster. So let's just take one small example of software dependencies. If you've been writing code the last 15 years, your developers have been taking dependencies. I mean, we only have to think about Equifax to know how even sort of, I won't call them legacy, mature organizations have been using software dependencies. Now, I'll give you the example of a very specific customer. Let's just say they are in transportation industry. They ran one of the SCA tools. They've been using it for about 18 months now, and it gave them 3,000 software dependency vulnerabilities, out of which there were 100 software dependencies that were causing critical SEV10 criticality vulnerability. 100. And when they went to the developers with this mountain of workload, as we've discussed earlier, they were laughed at, and they've made no progress whatsoever. Same thing, we applied the attacker reachability concept in that less agile organization, reduced that 100 dependencies to, in their case, 3% instead of 4% that I talked about earlier. Now that becomes suddenly far easier to do. And the software development team went through the exercise of finding out, okay, what is it going to take for us to upgrade these 3 dependencies? They did realize that there was going to be a fair bit of work. It was not just upgrading the dependency, but because it became a problem that they could tackle, they went ahead and did it. So all SEV10 criticality vulnerabilities in this organization from a software dependency point of view have now been eliminated. So accuracy of application security, being able to speak the developer language through data flows, being able to insert the vulnerability information wherever the developers might want to see it, all of these facets remain true regardless of who you are.
Yeah, I think that's a great message. I think, speaking of reachability, to get this message out to reach our audience, that idea of the accuracy, the context, and rather than just say, here's everything that must be fixed, here's a good prioritized list of here's what's important, and here's a backlog for when you get down to it. I think that's a really great message that gives just makes that relationship between security and developers much better, because you have a richness of good context of information. So I want to thank you for that message, Manish, and for joining us today and giving us a good insight on how we can introduce better AppSec into legacy and modern CI pipelines, for that matter.
Thank you, Mike. It was a pleasure. And thank you, John, for taking the time.
Well, I thank John. Thank everybody for listening. And if you'd like to learn more about ShiftLeft, visit securityweekly.com/ShiftLeft. We're going to take a quick break now and return with news of the week.
We discuss application security a lot on this show, and we know that the implications for code security have become even greater as cloud adoption accelerates software development. ShiftLeft bridges the gap between security teams and developers to find and fix vulnerabilities accurately from the source. ShiftLeft Core is an innovation in code security with industry-leading accuracy and speed. It combines next-generation static code analysis, intelligent software composition analysis, secrets detection, security insights, and contextual developer security education in one easy-to-use platform. Learn more and create your free account at securityweekly.com/ShiftLeft. Cloud-native development presents new challenges for security teams. Ephemeral workloads are scattered across services, and it's hard to identify resources, monitor configurations, and ensure compliance. Prisma Cloud by Palo Alto Networks is a comprehensive cloud-native security platform, delivering full-stack protection for multi- and hybrid cloud environments. It provides deep visibility, threat detection, and data security, as well as protection for hosts, containers, and serverless while enforcing policy guardrails. Visit securityweekly.com/Prisma Cloud to gain control over your cloud security. Whether you need to manage bots, protect cloud applications at runtime, stop formjacking attacks, or secure your web applications and APIs, only Imperva offers a unified solution to protect from edge to application and data in one tool. Imperva helps you achieve more, save money, and become more efficient with fewer security vendors needed. Start a free trial today to easily protect your apps and website with Imperva. Learn more at securityweekly.com/Imperva.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by John Kinsella. Do you want to stay in the loop on all things Security Weekly? Visit securityweekly.com/subscribe to subscribe on your favorite podcast catcher or our YouTube channel. Sign up for our mailing list. Join and chat with us in our Discord server and follow us on our newest live streaming platform, Twitch. In our May 27th webcast at 11 a.m. Eastern, we'll explore the latest attacks against DNS and the latest techniques that makes it possible to discover and disrupt those attacks. In our June 3rd webcast at 11 a.m. Eastern, you will learn about pen testing tools and why every organization should be using them regularly. Register now at securityweekly.com/webcasts. If you missed any of our previously recorded webcasts or technical trainings, they are available for your viewing pleasure at securityweekly.com/on-demand. Finally, Security Weekly is elated to announce that we will be at InfoSec World 2021 in person this October 25th through 27th, 2021. This year, our annual partnership with InfoSec World is extra special as we are both business units under the Cyber Risk Alliance brand. What does this mean for Security Weekly listeners and InfoSec World attendees? Well, you get to see and hear from many of the Security Weekly team at the event. And you can also save 20% off your World Pass. Visit securityweekly.com/ISW2021 to register using our discount code. Now, John, we have the news, and I jinxed us last week. Here, I dove into a 20-year history of IIS, bringing out the double decode vuln, saying how great it was that post that era. Microsoft invested in a lot of hardening. We hadn't seen any significant vulns in IIS for a long time. And then guess what? Some Microsoft internal researchers say, oops, there's a HTTP protocol problem here in IIS that not only is exploitable, but it's wormable. So, so sad. But it's a special
20th anniversary vulnerability.
That's right, 20th anniversary vulnerability. The good thing is, to put it a little bit of perspective, it's on recent HTTP protocol stacks, or at least recent versions of Windows. So it's not necessarily as pervasive and as a internet-breaking type of vulnerability or worm that we're going to see in the ancient days of NIMDA and so on. But the one thing that did actually stand out to me is that, for as much as I'm joking a bit about this nice 20-year-old anniversary worm, is that there still was a lot of hardening. But I'd love to know, how do they find this, in the sense of, was this from their fuzzing, and they have great fuzzing tools that are just helping to make this hardened IIS stack remained hardened, and was it in some legacy code, since that's, I think, our word of the day for this episode, or was it actually in some new code? And the reason I asked that, in the sense of, Maybe if it was an older code that was just waiting to be discovered. But if it's a new code, it's kind of interesting to see how these vulnerabilities can still be reintroduced, and how do we get into that sense of who cares about SQL injection or who cares about memory safety anymore, because we just have better tools, better APIs, better language primitives that we're using, that we don't even have to worry about those types of vulns. So that's where my mind went when I saw this. So nothing earth-shattering other than, sorry, IIS.
You know what? It was interesting to me, and I'm still sort of taking in the details. I'm not sure if it exists. My initial thought was it existed. It's a new vuln, newly introduced, but as I look closer, it's not really clear to me. But I'm just thinking about this from the point of view of, like, we always talk about CI/CD and bringing it back to the last segment about how many times can you scan your application per day. How many times do the malicious actors out there have to rescan an operating system looking for new vulnerabilities which have been added? I mean, what's that process like, right? That seems sort of like a boring job for somebody to have to, after you've gone through everything, now you have to go back through again and look and see if there's anything new or different. That's got to work on automating that part.
What's new or different, or as well as, I think, to your point, who's looking at either the old and crusty parts of the code, or who's looking at the code with fresh eyes? And that, what you just said also made me think of the XM vulns that Qualys discovered, 12 years after the fact, just by, as far as we know, just doing a really good source review audit. So maybe there's still some worthwhile bugs out there to find.
And they actually had on, was it Paul's Security Weekly last week? For people who want to go and listen to an interesting episode, they had one of the core researchers that was working on that stuff. It was a fun conversation to listen to.
Yeah, go spread the love throughout the rest of the Security Weekly family. Also spreading the love for all things vulnerabilities. There's an article about So Long Internet Explorer. And of course, it did say so long. It avoided the cliche of so long and thanks for all the fish, although I don't know how you could figure out how getting fish in there is a good metaphor other than perhaps phishing against browsers. But I pulled in this article not so much specifically to talk about Internet Explorer. It's gone, been replaced by Edge, but Edge at its core has the same core of Chrome, for that matter. I wanted to more have this kind of here's one browser going by, but what if we reflected a bit on the history of HTML standards, and browser security? And to my mind, I think we've seen a lot of positive trends in the sense of browser architecture changes, in the sense of process separation, using RPC calls to shuffle back data from process to process, that makes it a little less impactful in terms of memory safety issues within the JavaScript sandbox. Those can't leak over into stealing cookies out of memory or keys out of memory, secrets, that type of thing. So I think there have been a lot of positive trends. And another trend that we've also seen is that HTML actually today is pretty much more standard. Now, we could argue that it's more standard because there's pretty much just Chrome, Safari, and yes, I won't forget you, Firefox, out there. So we've got kind of a consolidation of browsers of just implementing. But, in 2021, HTML standard is pretty much driven by the W3C. It was even just 2 years ago that the W3C, the WhatWG, the What Working Group, decided that rather than having HTML5 and HTML Next Generation, these two standards going in separate tracks, let's work together. And I think that's also going to help with just this idea of how can browsers implement security and implement sandboxing for the complexity of HTML and JavaScript a little more, where am I going with this? Standardize safely. So that was what I wanted to kind of riff on when I was thinking about the browser is dead, long live the browser.
Long live the browser. These things came out. Just make this a compact statement. These things came out in a point in time when we weren't thinking about browser security or HTML security. So as with one of the other upcoming articles here, we've realized over time to sort of separate these things out and compartmentalize the various components, which we should be doing so. What I'm interested in seeing is, as we go forward, whatever the next big thing is, are we going to learn and not repeat that same thing? I don't have very positive thoughts on that, unfortunately, but that's sort of where my head goes on this.
So you're possibly worried that Flash is also dead, but who knows when the next Flash plugin will will emerge. Well, I think speaking of sort of that idea of architectures and architecture security or platform security, John, I know you like reading, so this week I threw in a 35-page PDF. And so hopefully, the 5 or 10 minutes that you saw before the show, you had a chance to read that through. But to cover for you, in the case you need to finish a couple of those pages, I'll introduce this a bit. This is a article, or a more of a academic article talking about the Android platform security model. And it's in the ACM Transactions on Privacy and Security. But it sounds a bit stuffy, sounds a bit perhaps academic, but it's a really actually accessible read about some design principles behind Android. And I pulled this in with a couple of motivations. One is that if you are a application security tester, or if you're focused on application security in the mobile platform, specifically Android, this could be just a good refresher. What is a little bit of the history over the Android 4.x up to Android 11, that 10-year life cycle of Android security changes. But it also, I think, helps if you are a slightly more technical product manager, or even just you're an engineering manager, in terms of reading about what are other people doing, what are other platforms doing, and considering their approach to threat modeling, their approach to fundamental principles for building in access controls, building in this idea of consent from the user, from the developer, and from the platform. And all three of those actors have to agree before a behavior is allowed or a data access is allowed. And I think these are the types of things that can be helpful just to learn from others. And so it's that sort of spirit that we read other people's code, we could perhaps read other people's architecture decisions, other people's platform security models, and figure out what aspects of those might translate to our own systems. So I'm trying to look at this in that sense of generalizability and learning from one domain and transfer it to another.
Yeah, I don't know what the big concern is. I mean, it's really not a 35-page paper, because the last 6 pages are all just references.
Fair enough.
I did give it a quick scan. It was interesting to see the amount of mentions of both seccomp as well as, we're just talking about isolation separation. So there's an interesting graph in there chart showing sort of over the generations of crazy Android version names, how they're sort of separating out some of the components around the device drivers. That in SE Linux and seccomp, I'm always happy to see. I usually think of SE Linux as a Red Hat thing, so that's sort of interesting. Whereas a lot of the rest, at least in the container side, the rest of the world has gone towards AppArmor. But the quick scan in those 5 minutes might give me enough that I sort of want to go back and read this.
Well, and I think you pull out for me one of the really cool pictures that a picture that does tell 1,000 words, as well as perhaps a picture that shows that was built by 1,000 vulnerabilities, is they show that decomposition of the media server. And we've actually talked in the past about media server being that area that's rife. It's a great attack surface because you're dealing with user-generated content in the sense of audio files, video files, images that are easy to manipulate, tend to be pretty brittle libraries that are dealing with all of those different codecs, and it shows how over time they've decomposed that specific media server into components with fewer and fewer privileges. So a great evolution of sandboxing. So yeah, great to see. Another thing that stood out to me too was the idea of encryption of data at rest and the shift from full disk encryption to file-based encryption. And a little bit of the explanation of what the benefits are to each, both on usability. So with file-based encryption, you can actually unlock particular files or decrypt particular files so they can execute without needing the user's key material. In other words, you don't need the user to unlock those files so they could see perhaps a particular notification, a particular alarm, something like that. Of course, you still need your threat model to say what is the sensitive data that we want to have user interaction to unlock. But it was a pretty neat walkthrough and pretty neat mental shift into the sense of how can we still maintain a good security model, but accommodate interesting features and interesting things that developers want to do. So lots of neat lessons. So I encourage a read. It is a relatively quick read, and absolutely you can skip the last 6 pages of references to shorten it a bit. That will bring us to another shift. Now we're going to shift back from talking about architecture models over into our favorite topic, or least favorite topic of the year, of supply chain security. So I had a couple things on related to supply chain security. One is just a relatively high-level essay from NCC Group, a blog post that was pretty neat, that was just talking about the basics. It's a great way to share with a team, share with executives perhaps who don't have an appreciation for what supply chain security means, other than we don't want to be the next SolarWinds. And so it's boiling down to the idea of we need auditable artifacts that we can securely and transparently trace back to the human readable source code. So we've got a dependency that we've used. What was the source code that was ostensibly used to build that dependency? And was that source code to that artifact tampered with in any way? And that's kind of, the easy way to describe supply chain security, but there's lots of places that supply chain security can go wrong. And we've talked about that a little bit in the last segment and a lot in the last couple of episodes too.
Yeah, if you're doing anything with security this year and you're not talking about supply chain, then you obviously don't have a PR person. Sorry. I think that the where I'm stumbling around on this one is supply chain. The title itself, supply chain security begins with secure software development. I'm not sure I buy that. I don't think. Maybe I need to think through it more. But like when I think about that, you can have secure software development and you can have a supply chain. And secure software development will definitely consume a supply chain, but I don't think it really guarantees the existence of one. Like one of the examples, I can't remember what talk I was on last week, but somebody was using it as an example. I mean, Go comes with a SBOM built into it, right? Your Go mod and Go sum files. And I think maybe JavaScript has something, or excuse me, Node has something top levelish like that too, package.js, I think. So I realize those aren't the Cyclone DX what they're referring to in here, and there's another standard as well, is it's could be SPDX. But I don't know. I'm not sold on the overall title. I think what he covers in the doc itself is good for people who aren't up to speed on this. But again, I think at this point we're preaching to our own choir. We need to get out and get this outside our little podcast, I think.
I think so. And one of the things I wanted to highlight too is that also try to pull in tools, other things. One of the tools that came up was reading TLDR Sex, shout out to Clint, was this Tracy. And so we've seen here's an example of a tool that actually wasn't specifically designed for software supply chain, but kind of just a blog article talking about how to adapt a particular tool and profiling, using eBPF to profile system activity and say, this is how you can bring some monitoring, some observability into your build systems, essentially. And so I think we're going to see a trend of either readapting existing tools into deeper or across the supply chain components and figure out what do we need. In this case, it was looking at just making sure that there's no malicious access, there's no malicious processes being spawned. So it's more of what am I trying to say here? That retroactive observability, or perhaps a forensics perspective on it, as opposed to that integrity preservation in the sense of here are signed commits, signed builds, signed artifacts. So I think you're right, is that we need to explore a little bit more about what are the pieces necessary to get to an SBOM, so that we say, yes, here is just what everything is within our package, but that package was also built in a secure manner, step by step, and it didn't leak credentials. It didn't introduce an expanded attack surface that would surprise us after the fact.
Yeah, this looks. I haven't got a chance to play with it yet. This looks interesting. The fact, it looks like basically they're using eBPF to gather the data, and then what do you do with it? But yeah, right. This is in a way as another form of I guess. well, I want to call it static analysis, but I think they're doing a little dynamic. There's multiple ways to sort of go around solving this problem, and it probably is going to take a combination of a bunch of these different tools, but this looks like it has potential to help out.
There's speaking of potential to help out, the other callback to last week's episode was we talked about complexity versus security, which actually emerged out as bad design is what in many cases weakens security. And that's bad design in tools, bad design in processes, bad design in user interfaces. And I pulled in this multi-instance service disruption from Salesforce, roughly, what was it, a 24 or 48-hour outage that hit Salesforce that boiled down to DNS. It's always DNS, of course. That's the eternal joke that will always be true. But what was interesting about this is that, one, I do like the idea of seeing relatively transparent postmortems. And there were a lot of lessons if you look through this and the technical details and their root cause analysis. And three things that at least that they called out was a lack of automation with safeguards for their DNS changes. So that sounds like weaknesses in the design of their tooling. There were insufficient guardrails in the change management process. So again, sounds to me like a bad design in process. And here's a little bit judgmental, and this is where it may go not quite off the rails, but subversion of the emergency break fix process. This is starting to get into that sort of blame the user aspect of the postmortem here, or blame the user, when we actually have to ask ourselves, was this EBF process, this emergency break fix process, was it actually misused? Or is it a little bit easier to say after the fact, this was really embarrassing, and in fact we had a insider working under the guise of a good actor in the sense of trying to fix something, who made a universal rollout of a DNS change that just so happened to trigger a cascading DNS outage. And if something is that brittle, maybe it's not so much the user's fault, or it's just you can always pin the blame on one person in this case. So that felt a little bit of an antithesis to the idea of a good blameless postmortem, or a good introspection in the sense of, what should we have fixed here? What could we have done better? So process helps people rather than just saying, oh, this was a human error, let's move on, like the Phil Venable article cautioned against.
I mean, it's pretty great from the point of view. It's for a RFO reason for outage. It's a really great post, right? I mean, it's pretty long and pretty meaty, and they're asking the right questions. And I think anybody out there, if you're doing anything even close to operations, just go through and just take their questions they're asking. What precipitated the chain of events? How frequent are DNS changes made? Blah, 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 blah. What went wrong? Just having this list of questions to ask internally, not alone be brave enough to post out to the world in a post like this. That's a really great thing. I'll editorialize, which I guess is what I do here, a little bit in that saying, two things. One, I've told people before, I'll tell people again, don't run your own status site. You let a third party run your status site for this exact specific reason. And now I've got that off my chest. The second thing around that is, I bet there's a lot of Salesforce people that were part of their sales pitch was, hey, you don't want to be running your own sales automation software like Sugar CRM. You should be trusting a third party who can do it right. And that's always a little tough. And none of us are perfect, so this stuff's going to happen. And yeah, I'm at that point, I'm gum flapping, but good. Still think it's a good read.
It is still a good read. And the other thing is really nice too, just to add to what you said, is, as I always do, is at the end of it, those next steps. And those next steps should be a great shout out to all the project managers out there, because look at, it's broken down into what's in progress, what's completed. There's some dates. There's actually some specific actionable items that were laid out quite transparently here. So kudos for that, for as much as, perhaps it's not necessarily a good look for a lot of perhaps what their marketing marketing content might have been, or sales content might have been preaching. But there's another article here that I also pulled out, reaching back, as I always do, into the history of application security. This one is a little bit, maybe a tenuous connection to application security, but I'm going to get one in there. Just wait, John. Wired had a great article about the RSA hack. So this happened 10 years ago. And it was an insight that I don't know that it revealed too much new and insightful about what happened when RSA was compromised and the seeds to the RSA tokens were extracted. What was, to do a quick summary for those of you who aren't as familiar with that specific history or don't want to dive into the article yet. It started off with a user in Australia clicked on a link essentially or opened a Excel spreadsheet. That Excel spreadsheet compromised their endpoint. From that endpoint, there were two teams, in fact, of these attackers that pivoted all the way from that endpoint in Australia up to their manufacturing systems that were air-gapped, at least air-gapped on paper, but when you have a firewall connection, even if it's a one-way firewall connection, that doesn't sound like an air-gap to me. But what this meant was that the seeds, the cryptographic seeds for these one-time number generators could now be reused, and you didn't need access to the hardware token. You could just create your own virtual ones ad hoc. Now, the message here that I wanted to tie into Application Security Weekly is using this as a tabletop exercise. Just, John, as you were mentioning about, read through the questions that were asked in the outage article that we were just talking about from Salesforce. There's a lot of questions you can ask here to your development team in the sense of, where are our most critical assets? Where are our most critical certificates? If we're using certificate-based service-to-service authentication, where are our root CAs? How are they protected? Could new CAs be minted? What happened? What would happen if someone got compromised our root CA and could mint service-to-service connectivity? So there's a lot of these types of tabletop exercises that I think could be reproduced here, or this article could be used as perhaps some inspiration for that type of thinking.
Yeah, it's interesting. I mean, it's definitely, I can't believe it's been 10 years, but it's interesting for folks to go and just, remind yourself, even the big guys can get hit, right? They weren't being 100% perfect, but still it sounded like they had done a pretty good design on this. It sounds like the guys themselves that were actually working on this were shocked to see that it had been, the ops guys were shocked to see it had been compromised. So, there's always space for improvement. Keep listening to Application Security Weekly.
There we go. We should just going to end the podcast right there.
Like and subscribe.
Message. Thanks, John. Like and subscribe. I do have, I guess, two final things. One is just a quick shout out to a fun KubeCon presentation that a lot of people were talking about, that I thought was really neat in this era of virtual conferences and virtual presentations. One is just, the title is the aspect of hacking into Kubernetes security for beginners. So that's the title. And it could have been a kind of static, monotone presentation reading off slides bullet by bullet, which everyone would fall asleep to. Or it could have even been a more dynamically vocalized reading off every single bullet from a slide. But it was not. It was a pretty fun production values to see a journey, essentially, the life of a Kubernetes dev trying to get their work done and running into some points of friction and running into some conflict with the security team. And I thought it was kind of a fun callback to the idea to our last segment, in the sense of application security, developers working together. What is a counter example of not helpful collaboration? And so you can use that as sort of a lesson to say, oh, this is what better collaboration could look like. And it was pretty neat just to see that. And a couple of key phrases that I loved was starting off in the sense of, I'm not calling the security people, they are not fun. So if that's what your developer, if that's kind of the developer attitude, that's a signal right there. That's one of those metrics to adjust. One of the other things I'll say, shout out to Kubernetes, was the comment was, yeah, the documentation was right. So good documentation is good documentation to have. And I will say, one of my favorite quotes that I may have to adapt and use in the future is that we're made of stars, but your RBAC shouldn't be. So I just thought that was a great line. So John, don't know if you had a chance to watch this one or if you'd seen this one before, or any of the other presentations at KubeCon, but this was a neat one. This stood out to me.
I'm embarrassed to say I haven't watched this one yet. I saw it got awesome press coverage, which is great, right? It's like, again, as I was just saying, we need to get our security people talking outside of our little bubble. So they weren't giving this talk at the Cloud Native Security Day. They gave it at KubeCon, which I think is awesome. They're all awesome people. I think I've worked with all of them now at CNCF or Kubernetes, different working groups and stuff. So yeah, not surprised. This is a great little bit of security entertainment. How about that?
Yeah, and to your point too, I'm trying not to just repeat everything you say, but you say a lot of interesting things. And I think the important point you said was this was geared towards developers, and that's the message to bring. I mean, you even mentioned earlier in this episode, John, that we're kind of preaching to the choir about just what is supply chain security. And yes, I'm trying to avoid using the phrase solar winds. Every time I say that, I think of honestly, I think of Spelljammer for you D&D fans out there, and I want to come up with something like Phlogiston and Astral Breeze and talk giant space hamsters instead of APTs. So that will be my own editorial riff. But the editorial riff here was that why don't we talk about security to the developers in the way the developers need and where the developers are? So rather than invite the developers or expect them to come to all of our security conferences, let's bring that security message to the developers' conferences. And even better, as this one did, let's bring that message in a great communication skills and a great narrative. So definitely fun. Yeah. Go check it out. Of course, after you've watched this episode of Application Security Weekly. That sounds like a great message to end on, John. Anything that you think we should wrap up here before we say goodbye and depart onto another week of reading up on what happens in the news?
I think that's I'm going to have to go watch that video next. That's my thing. My talk I was just checking, which I did at Cloud Native Security Day, is out on YouTube. Maybe we'll talk about that a little bit next week or two. I did a pretty interesting talk about security nutrition labels for open source projects. So for people who need a little more watching, they can watch that, or hopefully we'll talk about it in a future episode.
Sounds like a tasty topic. And it also sounds like this time I've got some homework to do to go watch that video. So thank you for that, John. The tables have been turned. And speaking of turntables, I hope you're always enjoying the Security New Wave Post-Punk Security Hour. I want to thank John for joining me. I want to thank everybody in the Discord channel for chatting with us along as we chat as on the episode right now. And want to thank everybody for listening, like, and subscribe. We'll see you next time on Application Security Weekly.